This video is on Chapter 17, Lesson number 2 on theoretical probability. For theoretical probability, it says here that probability is the measure of how likely an event is to occur. The set of all possible outcomes is called the sample space. For equally likely outcomes, the theoretical probability of an event, P of E, is the ratio or fraction of the number of favorable outcomes to the total number of outcomes possible. So that's the part of this that you need to make sure that you know. For probability, for theoretical probability, we need the numerator to be favorable outcomes, and the denominator is the total number of possible outcomes. So let's look at some examples here in this section. Number 1 says a jar containing 32 red marbles and 28 blue marbles. What is the probability that a randomly selected marble is red? So favorable means picking a red marble. Out of my jar, there are 32 red, so that will be my numerator. And then the denominator is the total, so you're going to add your 32 plus your 28 to get 60. And then always, always, always make sure that you reduce that fraction, and it's going to be 8 over 15. And in this section, I should have said this before, for simple events, the probability of just one event. So one thing is happening here. Let's talk about number 2. A letter in the word restoration is randomly selected. What is the probability of selecting a vowel? So we have to know what a vowel is, A-E-I-O-U. And in the word restoration, I see 5 vowels. So that is my favorable, selecting a vowel to the total, which is going to be 11 letters in that word. And 5 over 11 does not reduce. Let's look at number 3. A day in the month of January is randomly selected. What is the probability of selecting a prime number? So I feel like sometimes the hardest part is the vocabulary that we've got to get past. And you have to know what a prime number is. A prime number is any number that just has 2 factors, 1 and itself. So the number 1 is neither prime nor is it composite. So basically, because January has 31 days in it, we have to figure out how many of those numbers from 1 to 31 are prime. Well, I just said 1 is not prime. 2 is prime, 3 is prime, 5 is prime, 7 is prime, 11, 13, 17, 19, 23, 29, and 31. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 out of the 31 are prime. And again, that does not simplify. Let's look at number 5. What is the probability of drawing a heart or a club from a standard deck of cards? In a standard deck of cards, you have 52 cards total. There are 4 different suits. And in each suit, there are 13 cards each. Each suit, there are diamonds, hearts, clubs, and spades. And it's asking me what is the probability of drawing a heart or a club. So that would be 26 out of the 52 cards, which is going to reduce to 1/2. All right, let's look at the next section here. It's called complement of an event. The complement of an event is the probability of the event not happening. Not happening. Since the sum of all probabilities in sample space is 1, the probability of an event not happening, P of not E, is 1 minus the probability of the event E. So let's look at example number 7. Number 7 says the probability that it will snow tomorrow is 7 out of 20. What is the probability that it will not snow? So we're going to take 1 minus 7 out of 20 to get the complement, which is 13 out of 20. Let's do a couple more here. Number 8, a month of the year is randomly selected. What is the probability of getting a month that does not begin with the letter A? So sometimes, especially when you've got the word not involved, you really kind of have to think. And counting the months that have an A is easier than counting the months that don't have an A. If you go through each of the months of the year, there would be 2 of the 12 that begin with the letter A. So for the not, it would be 1 minus 2 out of the 12, which is going to give me 10 out of the 12, or 5/6. Let's do one more. Number 10. 2 dice are rolled. What is the probability of not getting doubles? Now, this is a perfect example of I do not want to come up with that list of not doubles because each dice is different. Each die is different, and I don't want to come up with that list. So how many doubles could we get? If I roll two dice to get a double, there's 6 ways to get doubles, right? So because you got double ones, double twos, double threes, double fours, double fives, and double sixes. So there's 6 out of, remember your fundamental counting principle here, the total would be 6 times 6, or 36 for my denominator. So the complement, to adjust this for that word not, we need 1 minus that, which is going to be 30 out of the 36, which is going to reduce to 5/6. All right, next section is compound events. This is when we have 2 or more simple events. You have an independent event and a dependent event. With independent events, when the outcome of one event does not affect the outcome of the other event, to find the probability of A and B, you find the probability of A and multiply it times the probability of B. If you have dependent events, that's when the outcome of one event does affect the outcome of the other event. To find the probability of A and B, you find the probability of A, and then you multiply it by the probability of B after A has occurred. So you're assuming that A happened, and you're going to find the probability of B and then multiply them together. So let's look at independent events first. Number 11. A die is rolled 3 times. So now we're talking about just one die, not multiple, just one die. That's the singular. A die is rolled 3 times. What is the probability of getting ones on each roll? So for roll number 1, the probability of rolling is a 1 is 1 out of 6. And then I'm going to pick that die up and I'm going to do that again. So each time the probability is the same. So 1 out of 6 times 1 out of 6 times 1 out of 6 is going to give me 1 out of 216. Let's look at the next little section here. This is still independent events, but we've got a scenario. A bag contains 8 red crayons, 14 purple crayons, 6 yellow crayons, and 4 green crayons. A crayon is selected, replaced, then another is selected to find each probability. So the reason why this is included in the independent is because when I select a crayon, I'm going to put that crayon back in the bag. So each selection is independent of the other. So let's look at number 13. Number 13 says find the probability of a purple, then yellow. Well, for the probability of purple, there are 14 purple crayons. And you would have to add all these up. So 8 plus 14 plus 6 plus 4. Y'all, there are 32 total crayons in the bag. So to select a purple, there are 14 out of 32 ways to do that. And then I'm going to multiply that. I'm putting that purple crayon back in the bag. And then I'm going to try to select a yellow. What's the probability of selecting a yellow? Well, there are 6 out of the 32. So you're going to put that in your calculator to multiply those two fractions together. And you're going to get a final answer of 21 out of 256. I want to look at number 15 as well, the probability of selecting 2 purples. So again, this is completely independent. The probability of a purple, we've already said, is 14 out of 32. And then I'm going to put that crayon back. So the probability of selecting a second purple is again 14 out of 32 for a total of 49 out of 256. So let's jump to our dependent events. So with this section, the second event is affected by the first event. So using the same example from above, so we're still talking about that same bag of crayons, assume once a crayon is selected, it is not replaced. So what you're going to pick a crayon and you're not putting it back in the bag. Find each probability. The reason why this is dependent, y'all, is because when you select a crayon out of that bag, you no longer have 32 crayons in that bag. You now only have 31. So let's look at number 17. Number 17 says, what is the probability of a yellow and then a red? So for our yellow, going back to the yellow, there were 6 yellow crayons out of the 32. So 6 out of 32. And then I'm going to set that crayon aside. And then it says find the probability of selecting a red after that. So what's happening here, y'all, in the formula I wrote at the top of the page, for the second event, you are assuming that the first event occurred. So the probability of B, assuming that A occurred. So we're going to assume I selected a yellow crayon. For the red, there were 8 red crayons. So I'm going to multiply this by 8 over. Now there are only 31 crayons in the bag. And put that in your calculator, multiply your fractions, and you get 3 out of 62. One more, number 19. I need the probability of 2 red crayons. So for red, if we go back to that example, there are 8 red crayons. So the probability for my first event is 8 out of 32. But for the second one, the second fraction, I'm selecting red again. Well, again, remember that you are assuming that the first thing happened. So I'm assuming that I took out a red crayon. So there are no longer 8 red crayons in my bag. There are only 7. And remember, there are still only 31. So that gives me a probability of 7 out of 124. So there is your basic, very basic probability, theoretical probability for lesson number 2.